Hi. Okay, so if you can turn to page 11 of your functions packet, today what we're going to talk about is something called inverse functions. Now, to find the inverse of a function, all you have to do is swap the x and y values. Okay, now this isn't in your packet, but I'm just going to show you real quick. So for example, let's just say I had a graph here that went through the point 1, 0, 2, 1, and 5, 2. If I wanted to graph the inverse of this function, all I would do is I would reverse the coordinates. Instead of graphing the point 1, 0, we're going to plot the point 0, 1. We're just switching the x and y values. Okay, and instead of graphing the point 2, 1, its inverse would be 1, 2. So I'm going to go over to 1, up to 2, up to 2, and put a point. And then instead of graphing the point 5, 2, I'm going to graph the point 2, 5. Okay, and this right here would be the inverse of the graph in red. Okay, so all I'm doing, let me just label this, I'm taking the x and y values and I'm just flip-flopping, I'm switching them. Okay, now if you remember from geometry, when you do that, all that really is a reflection in the line y equals x. Okay, if you were to graph the line y equals x, it looks like this. If I were to reflect this red curve in that line y equals x, it would wind up right here. Okay, so now we're going to do some of the examples in your packet. Now, with the examples in your packet, rather than being given a graph, you're given an equation. And what we want to do is we want to write the inverse of this equation. Okay, the steps for it are right up here. Now, if the equation has an f of x instead of a y, you can substitute the f of x with a y. And the reason we can do that is so that we swap the x and the y variables. So if we look here, we don't even have an f of x. It starts us off with a y. So what we're going to do is we're going to change this y to an x, and we're going to change this x to a y. Okay, so now what we have to do is we just have to solve for y in this equation. You want to get y by itself. So in order to do that, we're first going to subtract 2 from both sides of the equation. So that leaves us with x minus 2 equals 3y. And then to get the y by itself, just divide both sides of the equation by 3. Okay, so we have a y on the right-hand side of the equation. Now you have to look at the answer choices. They didn't leave the fraction like this. What they did was they individually divided each of these terms in the numerator by the 3 in the denominator. So instead of having x over 3, what they did was, since there's technically a 1 in front of this x, they wrote this as 1/3 x. And then we can bring down this minus sign. And then 2 over 3, we would just leave as 2/3 because that doesn't simplify. So we get y equals 1/3 x minus 2/3. So if you look at letter C here, y equals 1/3 x minus 2/3, okay, that is going to be our answer. Okay, number 2. Now if you notice, this one gives us an f of x. You can just take that f of x if you want, and you can replace it with a y. So we would have y equals -6 times x minus 2. Okay, so now what we want to do is to find the inverse. We want to switch this y to an x, and we want to switch this x to a y. All right, so we'll have x equals -6 times y minus 2. Okay, so we have to get y by itself in this equation. I mean, there's a couple different ways you can do it, but I think the easiest way is to distribute, get rid of the parentheses first. So I'm going to distribute this -6 to both terms. So when we do, we get -6y and then positive 12, right? Okay, so let's get the y by itself. So I'm first going to subtract the 12 from both sides of the equation, which leaves me with x minus 12 equals -6y. And then let's just divide by -6. Okay, now, first thing I'm going to do is, since the original function had an f of x, right, we don't want to leave this as y. We want to change it back to function notation. But since this is the inverse, we haven't seen this symbol before. Okay, if you're given a function f of x, this little symbol right here means f inverse of x. It almost looks like a little exponent of a -1, but it means f inverse of x. So I'm going to change this y to f inverse of x. And if you prefer to put it on the left-hand side of the equation, I mean, normally you do write this first, and you can see in the answer choices they write it first. You could totally do that. I'm just bringing it down to line it up. But if you look at our answer choices, again, it looks like what they did was they individually divided. It's going to be a little hard to see this, but they individually divided these terms by -6. So here, if you take an x and put it over -6, it'll give us x negative, x over 6. Doesn't really matter where you put the negative. You could just slide it in front of the fraction if you want, or you could put it in the numerator or the denominator, one or the other. That's up to you. And then -12 divided by -6 is +2. Now, if you look at the answer choices, okay, f inverse of x, again, they put first. And then what they did was they put the +2 first and the negative x over 6 second, which, okay, the commutative property says you could just change the order of these, so that's what they did. So choice 2 would be our answer. Okay, if you want to try one on your own, you can just pause the video and try this one. This is a good one to try. And then just hit play and see how you did. Okay, so in order to solve this, right, we know that f of x really means the same thing as y equals, as y. So I'm going to rewrite this as y equals 1/2 x minus 3/2. Okay, now to find the inverse, we have to switch the x and the y. So I'm going to make the y and x. I'll do it down here. And I'm going to make that x into a y. And now all we have to do is just solve for y. All right, so I'm going to add 3/2 to both sides of the equation. There's a couple ways you could have started this. If you wanted to get rid of the fractions, you really could have multiplied both sides of the equation by 2, and it would have gotten rid of these denominators, but I'm just going to stick with the same process we've been doing for the others. So these cancel off, and I'm left with x plus 3/2 being equal to 1/2 y. Okay, now, this is where I'm going to do it a little different than the others. With number 1 and 2, we divided by the number in front of the y. So, I mean, I could divide both sides of the equation by 1/2, but then I'm going to have a fraction over another fraction. It's going to be kind of a mess. So rather than dividing by a fraction, what you can do instead is you could multiply by the reciprocal of this fraction. The reciprocal means just take this fraction and flip it upside down. So if I multiply both sides of the equation by 2 over 1, okay, again, I'm just taking this fraction and flipping it upside down. So I'm going to multiply both sides by 2 over 1. What's going to happen is on the right-hand side of the equation, the 1 on top cancels with the 1 on bottom. The 2 on top cancels with the 2 on bottom, and I'm left with just y, which I am going to rewrite. Since they use function notation in the beginning, I am going to rewrite with this little f inverse symbol. And then on the left-hand side of the equation, let's just distribute. So 2 over 1 times x is just 2x. And then 2 over 1 times 3 over 2. When you multiply fractions, you multiply the top. So 2 times 3 is 6. And then 1 times 2 is 2. And 6 over 2 simplifies to 3. So we'll be left with plus 3. Another way you could have done that is you could have just said this 2 on top cancels with this 2 on bottom. So you're really just left with a 3. Okay? So it looks like this right here matches up with letter A. Okay, again, with any of these, if you want to at this point try them on your own, I would. That's only, going to help you. I would just hit pause, try it, and then you can hit play and see how you did. Okay, so the first step here is we are going to switch the x to a y and the y to an x. So I'll rewrite this as 2y plus 3x equals 6. Okay, so let's solve for y. So I'm going to subtract 3x from both sides of the equation, which leaves me with 2 y equals, and you could rearrange this as 6 minus 3x, or I'm going to write it as negative 3x plus 6. I'm just going to put the x first, because when you look in all the answer choices, they have the x first. Okay, and then let's just divide by 2. So that leaves me with, now, normally I would just bring down the y, because they started off with a y, but if you look at the answer choices, they did use function notation, so they did write f inverse of x. So I'll do the same. I'll write f inverse of x, and then equals, so negative 3 over 2x, and then plus 6 divided by 2 is 3, so plus 3. Okay, so it looks like that is letter B. Okay, so number 5, I'm going to first just rewrite this f of x as a y, so y equals, and then x minus 3 squared plus 1. Okay, so now it says find the inverse, right? Again, this symbol means inverse. So I'm going to switch this y to an x, and I'm going to switch my x to a y. Okay, so we have to solve for y, and I'm sure a lot of you, because you see the square here, are going to be tempted to write this out twice and double distribute, but then you're going to have y's all over the place, right? And that's what we're trying to solve for. So instead of doing that, what we can do is we can get this parenthesis by itself, and then we know to get rid of a square, we could just take the square root. So let's do that. Let's get that parenthesis by itself by subtracting 1 from both sides of the equation. So it leaves us with x minus 1 equals, and then y minus 3 squared. Now, to get rid of the square, we could take the square root of both sides. And remember, this little exponent here of a square tells us that we have 2 possible answers that could work, okay? When you take the square root, we want to write plus and minus in front of this side of the equation. So I'm going to write plus and minus. And then radical, you really can't do anything with that x minus 1. I'm just going to leave it as radical x minus 1. And then what happens is on the right-hand side of the equation, the square and the square root cancel off, so it leaves me with y minus 3. Okay, and then to get the y by itself, just add 3 to both sides of the equation. So it leaves us with, I'm going to write this, you could write plus and minus radical x minus 1 plus 3, but normally what you would do is you would put this 3 in front of the plus and minus. Okay, just kind of like when we do the quadratic formula, completing the square, there's a number in front of this. So I'm going to rewrite this as 3 plus and minus radical x minus 1. And then instead of y, I'm going to replace it with f inverse of x. Now, since this isn't multiple choice, I'm going to rearrange this so it looks nicer. I'm just going to put the f inverse of x first, and then the 3 plus and minus radical x minus 1. Okay, so that's our answer. Okay, so we're going to keep doing the same thing. Number 6 is, same thing as we've been doing. 7 and 8 get a little different, so you may want to watch that twice, or, that's up to you. Okay, so first thing I'm going to do, now this time they give us the inverse, and they want to know what was the original equation. Well, you're really going to do the same thing. If you switch the x and the y to find the inverse, we would do the same thing to go from the inverse back to the original equation. You just switch the x and y. It'll bring you back to where you started. So this technically we know means y, right? So I'm going to rewrite this as x. I'm going to write this side of the equation as an x. And then this x, we know we have to switch to a y. Okay, and let's just solve this. So let's solve for y. So I'm going to subtract 2 from both sides of the equation. So it leaves me with x minus 2 equals negative 3/4 y. Now, again, we have a fraction in front of our y. So rather than dividing both sides by negative 3/4 and kind of making a mess, like having a fraction within a division problem, let's multiply instead by the reciprocal of negative 3/4. Now, the reciprocal of negative 3/4, you want to keep the sign, is negative, and then flip that fraction upside down, negative 4/3. So we're going to multiply both sides of the equation by negative 4/3. Now, let me start on the right-hand side of the equation. All right, so we know a negative times a negative is a positive. And then this 3 on top cancels with the 3 on bottom, and the 4 on top cancels with the 4 on bottom. So really all we're left with here is y. Okay, now when I distribute, I'm going to have negative 4/3 x. And then a negative times a negative is a positive. And since this is a fraction, I'm going to make this 2 into a fraction by putting it over 1. And when you multiply fractions, you multiply the numerators, so 4 times 2 is 8. And then 3 times 1 is 3. So all they did in the answer was, instead of using y equals, they wrote it in function notation. They wrote f of x. And then let's just look for which one says negative 4/3 x plus 8/3. Okay, it's letter B. Okay, I find that number 7 and 8, people find these a little bit more difficult when they start you off with a fraction where you have the x on the top and the bottom. So let's just go through this, and then you may want to try 8 on your own, hit pause, and then watch the video and see how you did. Okay, so we know another way of saying f of x is y, right? So I could rewrite this as y equals x plus 5 over x minus 2. Now, to find the inverse, we switch the x and the y. So I'm going to switch this y to an x, and these x's to y's. All right, now, this is what makes it a little tricky. You want to solve for y, but we have 2 of them. We have one in the numerator and one in the denominator. Now, honestly, when you have a fraction being equal to just some term, I think the best way to solve this, in my opinion, is to take the x and put it over 1, make that into a fraction, and then we're going to just cross-multiply, okay? We're going to multiply across. Okay, so if I multiply the top left by the bottom right, I'm going to be multiplying x times y minus 2. I'm actually going to do this alone. I'm going to write that out. X times y minus 2. Okay, then I'm going to bring down my equal sign, and now I'm going to multiply the top right by the bottom left. So y plus 5 times 1. I mean, I'll write it out. You're doing 1 times y plus 5. Okay, so now from here, we're going to distribute. So when we distribute, I'm going to distribute the x to both terms, so that'll give me xy, and then minus 2 times x is just 2x. And then on the right-hand side of the equation, when you distribute a 1 to both terms, it just stays the same. It stays as y plus 5. Okay, so this is where, it gets a little tricky, but we have y's on both sides of the equation. And if you want to solve for y, the first thing you have to do is you have to get them both on the same side of the equation. So I'm going to take any term that has a y, and I'm going to just move it to the left-hand side of the equation. Okay? And then I'm going to take any term that doesn't have a y and move it to the other side of the equation. So really what I'm doing here is I'm going to subtract y from both sides of the equation. I'll just line it up over here. That way, I don't have any y's on the right-hand side of the equation anymore. But I want to take any term that doesn't have a y on it, this term right here, and move it to the other side of the equation. So I'm going to take 2x and add it to the other side of the equation. Oop. Okay, so now these are going to cancel off. Now let's look on the right-hand side of the equation. I have a 5 plus 2x. Okay, this has an x on it. This doesn't. They're not like terms. So I have to just leave it as, I'm going to write it as 2x plus 5. Okay, and then on the left-hand side of the equation, this term, the xy, has an x on it, and this one doesn't. So they're not like terms either. So I can't combine them. So I'd have to leave it as xy minus y. Okay, if one of them has an x on it and the other doesn't, you unfortunately can't combine them. Okay, so now from here we have to think. We still have a y here and a y here. Yes, they're on the same side of the equation, but we have them in 2 separate terms. So how am I going to get the y out of both of these terms? Well, if you want to get the y out of both of these two terms, you can just factor it out, right? Let's just factor out the greatest common factor, which is a y. So if I factor out the greatest common factor, which is a y, okay, let's look at this first time. I had an x and a y, and I took out the y. So I still have this x, so let's bring the x down in parentheses. And then I'm going to bring this minus sign down. Now, I had a y, and I took it out, but I have to be left with something. So let's think about it. When you take something out, you're really dividing. Y divided by y is 1, so we're going to put a 1 right here. And then let's bring down the right-hand side of the equation. Okay, from here it's pretty straightforward. To get the y by itself, you're just going to divide both sides of the equation by what y is being multiplied by. So if we divide both sides of the equation by that x minus 1, that the y is being multiplied by here, what's going to happen is the x minus 1 on top will cancel with the x minus 1 on the bottom, and we've gotten the y all by itself. So all they did in the answer, let's see, is they took y and wrote it using inverse notation, okay, f inverse of x, and then here this is 2x plus 5 over x minus 1, which matches up with letter A. Okay, so number 8 is similar to number 7, and you may want to hit pause and try it on your own, and then see how you did. Okay, so here we know that f of x means the same thing as y, right? So we could rewrite this as y equals 3x minus 1 over x minus 7. Okay, so now what we want to do is we want to find the inverse. We want to switch the y to an x and switch these x's to y's. So we'll have x equals 3y minus 1 over y minus 7. Okay, so we're going to do the same thing. We're going to put this x over 1, and we're going to cross multiply. When you multiply the top left by the bottom right, you can write that out if you want as x times y minus 7. And then we bring down the equal sign. And then when we multiply the top right by the bottom left, that'll be 1 times 3y minus 1. Okay, so now to solve this, let's just distribute. So I'm going to distribute the x to both terms. So we get xy minus 7x. And then let's distribute the 1 to both terms. So that gives us 3y minus 1. Okay, so now we're going to move all the terms that have a y in it to one side of the equation. So I'm going to just move them. It doesn't really matter which way you move them. I'm going to take this and leave. I'm going to leave this here, and I'm just going to subtract 3y from both sides of the equation. So if we do minus 3y, I will have all the y's on this side of the equation because these are going to cancel. And then I'm going to move my terms without the y's, so this negative 7x, to the other side of the equation. So in order to do that, I'm going to add it to both sides of the equation. Okay, so these cancel. So now on the left-hand side, these are not like terms. This one has an x on it, and this one doesn't. So you're just going to have to leave it as xy minus 3y. And on the right-hand side of the equation, rather than writing negative 1 plus 7x, I'm going to write that as 7x minus 1. Okay, so now to get the y out of both of these two terms, we're going to just factor it out. We're going to factor out the greatest common factor of y. So when we do, if we had an xy and we took the y out, we still have an x. So let's bring the x down. And bring down the minus sign. And then here we have a 3y, but we took the y out, so we still have this 3. So let's put that in our parenthesis. And then bring down the right-hand side of the equation. Okay, so now we want to get this y by itself, so let's divide both sides by the x minus 3. And what I'm going to do is, instead of bringing down a y, I'm going to rewrite it using my inverse symbol, f inverse of x. equals, and then we have 7x minus 1 over x minus 3. Okay, so that is our answer.